Hello, my name is Minyan Song. Today I will introduce 3 agentic AI systems that I built using multi-agent workflows. Each system is designed to solve a specific task, from Python code enhancement to scientific paper summarization and document-based question answering. The first task is automated code reviewer. This system reviews and improves Python code. It runs in a loop where 4 agents collaborate: a critic, generator, code generator, test generator, and test executor. They repeat until the code is high quality and passes all the tests generated by the generator. So the first agent, code critic, will take in the raw code and accuracy and fail tests if they are available already, and it will output the evaluation score and feedback string. Based on the feedback, the code generator will output the improved code. The third agent, test generator, will based on the improved code, it will generate test cases. And the fourth agent, executor agent, will execute the test cases and output the test pass rate, which is called accuracy in the code, which is calculated by the number of passed tests over the total number of cases. So the evaluation, first I evaluated it with binary search algorithm. I gave just minimum amount of code to the system and made it build a whole algorithm, and only after 2 iterations the stopping condition was met and it output the perfect code. But the breadth-first search took more iterations, but after 10 iterations it actually didn't meet the stopping condition. The critic agent score was only 70 and test pass rate was 90, but the completed code was actually able to pass all the test cases from the lead code. That means the critic agent was scoring very conservatively, and the test cases generated by the test generator wasn't 100% correct. So the limitations are, the biggest limitation I thought is that iterative agent loop does not guarantee convergence or improvement by each and every steps. So suggestions are convergence strategy and fine-tuning of the model and each agent. The second task was to build a research paper analyzer. There are 4 agents here too. First, the ingester extracts the raw text from PDF or from a URL, and the parser will parse the raw text into sections. I use different strategies to parse. The third agent will summarize and analyze in parallel, and the fourth agent will combines all section summaries and analysis and output up to 300 words. So the biggest challenge I had was the inconsistent formatting of PDF and highly varied academic writing styles. So the system weren't pulling out the correct sections as the original. I tried 3 different strategies here: regex-based matching, in font-based detection with the rolling mean of font sizes and other conditions like boldness or weight, in page-based splitting as well. When I chose the regex-based matching, I thought preserving the original paper's structure could be meaningful, and that was right. The system were able to extract 7 sections out of 9, which is similar to the original. However, when you see the raw tokens, it's very varied and imbalanced by section. But that also preserved the original information. The original scientific papers will have less words in the abstract section and way more words and information in the methods and the main part of the paper. So I thought it this way would contain more meanings than the regular page-based splitting strategy. So the system were able to condense the original up to 90%. The limitation I thought is the system is still missing some sections. So we could try combining regex-based and the font-based detection. Also, evaluation could be better if we have human summary references, and we could build web-based UI with user response rating and suggestions. The third task was to autonomously route user queries over documents to appropriate module. I defined 3 modules or tools, which are summary, and search, and action. So when the query was given, if it requires high-level overview or summary, it will use the summary tool. If it needs semantic search, it will use a search tool. And if it's out of scope of the given document, it should use the action tool to ask for the external help. I used LlamaIndex library. So the pipeline would define how to parse the document, and it will create indexes, which is summary index and vector store index, and that will be used in summary tool and search tool. And router query engine, the default router given by the LlamaIndex pipeline will define 3 tools. But I also defined my custom router called embedding aware selector to have the router be able to access to the given content of the document and have more context. So it will calculate the embedding similarity score, and it will output top matching content, and it's going to be given to the prompt with the custom prompt rules. So I expected this router will resolve limitations of the default router. There were agents including tool agent, action agent, and merge agent. For now, the action agent was a placeholder. So the results. When I evaluated with the default router query with those questions, and I provided one paper that's explaining about the human activity detection with the sensor data. And when I asked as the edge case, I gave the query as where is the Georgia Tech located, but somehow the system was detecting this question not outside of the scope of the given document. Probably it has high relevance score to the document. So the system would connect the query to the search tool rather than the action tool, which I was expecting. When I used my custom made embedding aware selector, the results weren't better. It actually routed this main idea query to the search tool rather than the summary tool. So this system needed more fine-tuning. So the biggest limitation was the routing accuracy. Both default and embedding enhanced LLM selector were still misrouting, so fine-tuning should be done. And also we could try advanced joint reasoning between semantic similarity and query intent. And also the action agent for now wasn't connected to the external API, and I thought that should be defined by the specific use cases or domain usabilities. Thank you so much for listening. If you have any questions, please let me know. Thank you.